In today's video, we are finally building an electric boat, but first you need some context. About a year ago, I purchased an old outboard engine out of Marketplace and converted it to electric using this motor. That all went pretty well. You can still watch that video. The motor kinda sucks, not gonna lie. So when I got the opportunity to buy this piece of shit, I thought perfect, I'll just rip the old engine out, easy peasy lemon squeezy. It's off, it's off. Let's go. Oh, yes! I'm gonna shuck this motor as far as I can. The engine wasn't even close to the worst obstacle to get to this point. So let's scroll back and see how it all started. A good place to start was to get the electric motor out from the outboarder we're not longer going to use. As always, we now need a new adapter to join the motor to the new outboarder. All we need is that adapter, which... Are we 3D printing it? Now all of this I was of course live streaming, and so pretty soon the adapter and motor mount was sketched up and 3D printed. Also cut myself trying to hold it. My god. Whoa! So we could finally spin the motor up for the first time and everything checks out. It works great. So me and chat casually working on the boat probably scarred a sales rep for life who decided to check up on us. This is what I look like when I live stream. Transmitting the signal to the receiver. A few tries later, I got the adapter and mount to fit just about perfect, and here's the very first spin up. Got some chickens to keep me company and brought forward the grinder to cut some metal, a channel for the cables. I could then take the boat out for the very first test run. So I brought my dad to help ramp the boat, which single-handedly could have ended the project real quick. Unfortunately, I was pretty fast to realize that something was seriously wrong. We got a lot to do. We ought to build a ramp out of pressure-treated timber to hopefully not get in this situation again. Now these bombs are finally done charging. It took 3 days. The cell groups were so off in voltage that it took 3 days to charge. Now that will increase the voltage from 50 using these small batteries as we did in this test to 58. It doesn't sound like a lot, but hopefully that will give us that extra punch. So we gotta swap out this rat's nest of wires to this plug. None of this matters, however, before we can figure out what's wrong with the motor, or more specifically the speed controller. As I went above 50% throttle, these really bad vibrations would occur. Some weird vibrations though. It works really great and really dog shit at the same time. Also, having an electric motor with the inertia of an elephant right behind you, it's kind of sketchy, not gonna lie. Now is that the motor, the speed controller, or the batteries not being able to supply all the power? All I can say is that it doesn't happen when I'm on dry land. I can go full throttle right now and it will spin just beautifully. It's when the propeller is in the water with a heavier load that this happens. The most likely outcome is that I'm gonna have to sell a kidney in order to afford a proper speed controller. 10 times more capacity these have. 400 individual lithium cells between the two. Patently hot. I sneezed, all right. Where's my human shield? As loud as fuck. At this point, I was considering 3D printing a series of propellers to figure out at what diameter to pitch ratio would the motor stop choking and actually work. I never got around doing that, but I know RC Test Flight has done a lot of testing on propellers underwater with electric motors, so that might be something we try for next video. I'm going to get shot by the gassers for this, but you'll see the video you're watching right now speaks more and more truth. Yeah, I got some more space down here. If you can come up with anything creative, comment down below and I'll add it for the next video. Okay, as you know, for the past year I've sent numerous files to PCBWay in order to be either CNC'd or metal 3D printed. All you do is upload your file and it will provide you with a plethora of options in regards to materials to choose from. PCBWay also offers PCB manufacturing, and with their instant quote feature you'll get the pricing up front. My experience is that you'll have your new part just a week after placing the order, so check them out in the description below. Okay, back to the video. Okay, got some skateboard wheels for less resistance and some wood. Let's build a ramp. In case this ever fails, I'll clip that in right now, so you already know if it works or not. That will be a surprise for me later. Step on. I 100% agree with you. I'd be surprised too if this worked. Skateboard rollers. I 3D printed pretty solid mounts. I got 4 of them. I will elevate them and hopefully the V-shaped hole will just be able to roll right through. Oh yeah, I got a new propeller as well. I didn't tell you about that. Well, before I got the new propeller, I asked ChatGPT, as one apparently do, basically asking if a propeller with the same diameter but way less pitch would make a difference. A pitch number of 9 was the lowest I could find in a store for this specific engine. It gave me a pretty long answer. I didn't read it all, probably correct, but I only cared for this last paragraph. 40% less power sounds good enough for me, so me and my GF girlfriend, yeah, I got one. Driving our Swedish Volvo picks up the new improved propeller, and yeah, that's the story of the propeller. I made these ones unnecessarily long. They go into the water, but I didn't quite know the depth. Here we had already cut them and the ramp was looking pretty good, though totally would need more wheels and a gradual incline so that this could probably be avoided. We could start to load up the highly questionable batteries, try to wiggle our way out, and lower the motor into the water. Yeah, you can probably tell I was really excited at this point. The excitement would be short-lived, however. This is the very moment I realized it still wasn't working. I didn't have anything to lose, so I just increased the throttle slightly and it actually reached higher RPM and I totally could feel it. And this is just me saying that, yeah, the new propeller totally made a big difference, even though I still couldn't go full throttle. I can definitely tell that it does have more power. It still jerks like crazy, and that's not fun, but it totally works. The lower pitched propeller certainly helps. Look, this is great. Look at this, it's way faster than last time actually, it's way faster. I knew heat could totally be an issue. 5 minutes in, I felt the motor and it was just warm to the touch.
Motorn är... Ja, den är inte varm, det skulle jag inte säga. Ljummen, tesljummen. Vad är översättningen på det, älskling?
Fart warm.
Så vattenkylning, det får bli nästa grej.
But little did I know that what I was about to say here straight up changed everything.
Jag kör runt då och så kommer jag åka här rätt så snabbt.
Ja.
Så får du gärna fånga mig.
Ja.
And so I went and accidentally pushed the throttle higher than I had before, but also longer, which was the key here. Keep in mind though that I just thought that it would just vibrate if I pushed the throttle any higher, but this time it locked in, gave full 100% throttle, and here's my totally surprised reaction.
Yes! Yes! Woo-hoo! That's so good! That's so good! Woo-hoo! Electric fucking go! We gotta bring the GPS speedometer to see how fast it is. That's insane. That's actually fast. That's actually fast. Yes!
And all of this was generated by AI. All of that boating, and we're still using the same 3D printed adapter and motor mount. That's sick. Yeah, we still got a lot to do, water cooling being the primary objective, but also trying to resurrect the third battery, which has a cell group close to death. That way, with the new controller, we could have 90 volts, which according to my calculations is about 2.25 times the amount of power which we currently have. Nonetheless, happy to see that this was a success, and so thanks for watching, and I hope you will have a great day. See you again very soon. Bye. The camera is way over there. It's gonna take about, I'll say another 5 seconds before I reach it. 3, 2, 1.